This is the second video lesson for Unit 6A. In this lesson, we'll be learning how to balance a chemical reaction. Go to page 5 in the class packet. Motivation. What is wrong with the following chemical reaction? We have N2 plus H2 gives us NH3. Notice we have two nitrogen atoms, but here we only have one. Here we have two hydrogen atoms, but we have three here. So this reaction is unbalanced. We don't have the same amount of atoms on both sides of the equation. Learning target. At the end of the lesson, I'll be able to use different strategies to balance chemical equations. Homework will be number 2, which is a Junipod based off this lesson. There will be a quiz Junipod based off PowerPoint 1 and 2 for Unit 6A. All chemical reactions always must obey the law of conservation of mass, charge, and energy. So during a chemical reaction, atoms rearrange themselves to produce a new substance. So here's a cartoon of the laws of conservation. Here's the combustion reaction of propane. We are going to prove in this chemical equation the law of conservation of mass and atoms is conserved. The substances on the left are the reactants. The substances on the right are the products. So we're going to use a table to prove that the law of conservation of mass and atoms is conserved. So this is our table. In the middle is our elements. We only have carbon, oxygen, hydrogen in this chemical reaction. Now we're going to count the number of atoms of each element on each side. How many carbon atoms are on the reactant side? We see 3. How many carbon atoms on the product side? There is 1 carbon in CO2, but since we have 3 CO2s, there's 3 carbons. How many oxygen atoms are on the reactant side? 5 times 2 is 10. How many oxygens on the product side? 3 times 2 is 6. 4 times 1 is 4. 6 plus 4 is 10. How many atoms of hydrogen on the reactant side? I see 8. How many hydrogen atoms on the product side? So 4 times 2 is 8. So notice that the number of atoms of each element on the reactant side is equal to the atoms of each element on the product side. Therefore, the law of conservation of mass and atoms is conserved in this reaction. Is there such a thing as a law of conservation of molecules? Let's check. How many molecules do you see on the reactant side? There's 1 here, plus 5 is 6. How about the product side? 3 plus 4 is 7. So that is not conserved. Let's do another example. Here we have CH4 plus O2 gives us CO2 plus water. So I'll draw the Lewis dot diagrams on top. We are going to first check if the equation is balanced. So I set up a table. Keep in mind, the coefficient and subscript 1 is invisible. So here we only have 1 CH4 molecule. And here's only 1 oxygen in water. Let's do some accounting. How many carbon atoms are on the reactant side? There's only 1 carbon. How many carbons on the product side? There's only 1 carbon as well. How many oxygen atoms are on the reactant side? There is 2. How many oxygen atoms on the product side? There's 2 plus 1, that's 3. How many hydrogen atoms are on the reactant side? There is 4. How many hydrogen atoms are on the product side? There is only 2. So notice that the law of conservation of mass is not observed here because the number of oxygen atoms and hydrogen atoms on both sides are not equal. So this equation is unbalanced. So always assume that the chemical reaction is unbalanced unless stated otherwise on exams and on the regions. When balancing chemical equation, do we change the subscript or coefficients and why? Let's say we change the subscript, we added 2 next to this oxygen. What happens here? This is no longer H2O, but H2O2. This is hydrogen peroxide, which is a different substance than H2O. So we cannot change the subscript because if we do that, we change the substance identity. We can only change the coefficient. For example, if we added 2 in front of H2O, we still have H2O. But instead of having 1 water molecule, we have 2 water molecules. Since we have 2 water molecules now, the number of oxygen and hydrogen atoms on the product side is changed. we no longer have 2 hydrogen atoms, but 4. 2 times 2 is 4, and the oxygen atoms we have 2 plus 2 is 4. Notice that our hydrogen atoms are now balanced. We now have to balance the oxygen atoms. Notice on one side we have 4, and the other side we have 2. We need to double the side. So we're going to add a 2 next to this O2. So we still have O2, but instead of having one molecule of O2, we have 2 molecules of O2. So now we have 4 oxygen atoms on the reactant side. Now this chemical equation is balanced because the law of conservation of mass in atoms is observed, and this table proves it. So just to review, changing the subscript changes the identity of the substance. Changing the coefficient changes the amount of the substance. So when it comes to balancing chemical equation, we can only change the coefficient and not the subscript. Let's look at example 3. Here we have copper plus Ag plus gives us copper 2 plus Ag. Let's check if this chemical equation is balanced. We have 1 copper and 1 silver on the reactant side. We have 1 copper and 1 silver on the product side. Now let's check the charge. If you don't see a charge next to an element, that means the charge is 0. It is neutral. So the total charge of the reactant side is 0 plus 1. The total charge of the product side is 2 plus 0. So notice that the law of conservation of mass is observed, but the law of conservation of charge is not. So we have to balance the reaction until the law of conservation of mass and charge is observed. Let's first put a 2 in front of the Ag so that we have 2 Ag, and the charge of the reactant side is now 2. 0 plus 2 times 1 is 2. Now the charge of the reactant side is equal to the charge of the product side. But notice since we add this 2, we have 2 silver, but we only have 1 silver on the product side. So we need to now balance the mass. So now that we added 2 in front of the silver, we have 2 silvers on both sides, so the law of conservation of mass is observed as well. We will come back to balancing chemical equation with charge in Unit 14. Now I'm going to go over a general strategy in balancing chemical equation. It's called a counting table. You can see the strategy on page 6 in your class packet. So the first step is to draw the table and label it as reactant, elements, and products. Then you want to fill in this table to check if the chemical equation is balanced. How many nitrogen atoms on the reactant side? There is 2. How many hydrogen atoms on the reactant side? There is 2. How many nitrogen atoms on the product side? There is 1. How many hydrogen atoms on the product side? There is 3. So notice that this equation is not balanced. The next step is to figure out which element to balance first. So you want to pick common factors like 1, 2, and 4, and avoid prime numbers like 2 with 3. So if we look at this table, you can balance the nitrogen first because there's a 2 and a 1. You want to avoid balancing hydrogen because it has a 2 and a 3. Those are both prime numbers and they're not easy to figure out. The last element you want to balance is any molecule with only one type of element, not a compound, anywhere in the equation. So typically it'd be H2 or O2. If you look at this equation, that would be H2 and N2. So you can balance either one of these last. So let's balance the nitrogen first. We have 2 on the reactant side and 1 on the product side. So we need to double the amount of nitrogen on the product side. So we're going to put a 2 in front of NH3. So we have 2 nitrogens now. But since we put a 2 in front of NH3, we no longer have 3 hydrogen, but 2 times 3, we have 6 hydrogens now. Now the nitrogen atoms on both sides are balanced, so the coefficient of N2 should be 1, but our hydrogen is still unbalanced. We have 2 on the reactant and 6 on the products. So we need to triple the amount of hydrogen atoms on the reactant side. So if we put a 3 in front of H2, we now have 6 hydrogen atoms on the reactant side. Now, if you look at the table, everything is balanced. So this equation is now balanced. The conservation of mass is observed. Your final step is to double check whether your chemical equation is balanced using the smallest whole number coefficient. That means you cannot reduce the coefficients by the greatest common factor. For example, let's say you balance the equation as 2, 6, 4. This is not the smallest whole number coefficient, even though the conservation of mass is observed with 2, 6, 4. You have to reduce everything by the greatest common factor, which is 2 in this case. So you divide everything by 2, and you'll get 1, 3, 2 as your final answer. It is very important to balance the equation using the smallest whole number coefficient because sometimes on the region, they'll ask you to calculate the sum of the coefficients in the chemical equation. So once you balance it with the smallest whole number coefficient, you just add them up. That will be 1 plus 3 plus 2, which is 6. Remember to add the 1. Keep in mind, coefficient 1 is invisible, so sometimes people forget to add the 1. Now I want you to finish the rest of page 6 and page 7 on your own. Pause the video and resume once you want to see the answers. So here's the answer to question 2. Question 3. Question 4. Question 5. Question 6. And here are the answers to page 7. If you're struggling to solve some of the problems on page 7, I'm going to show you some strategies that will help out on certain situations. Here are 6 situational strategies. These 6 strategies are found on page 8 in your class packet, and they build upon the table method. Only use these strategies if you find them helpful. The purpose of these strategies is to help you under certain situations. The first strategy is to double the numbers to make it even. In step 1, let's try to balance it first using the table method. At this point, a lot of people get stuck because they see either prime numbers or odd numbers on the table. One simple method to deal with this is to double everything in the chemical equation. By doubling all the coefficients in the chemical equation, we turn any odd number on the table to an even number. So let's do that. Now that we double all the coefficients in the chemical equation, let's adjust the table. So now we have 2 copper, 4 Brs on the reactant side, and on the product side, we have 2 coppers and 6 Brs. Once you double everything, we can look at the table and the equation again to check which coefficient we must change or modify to balance. It should be easy to see that we now have to change the coefficient of Br2. Instead of 2 Br2, we need 3 Br2, so that we have 6 Brs on the reactant side. This chemical equation is now balanced. If needed, simplify to the smallest whole number coefficient. Let's look at one more example before we move on to strategy number 2. This is number 5 on page 6. Usually some people will have some difficulties with this question, but by using strategy number 1, it will make it a lot easier. So step 1, try to balance it. Same as before, people will get stuck at this point because they either have a prime number or odd number to deal with. So let's double all the coefficients. It will turn any odd number on the table to an even number. After doubling all the coefficients, let's adjust the table. Now we have 4 hydrogens on the reactant side, 4 oxygens on the reactant side. On the product side, we have 4 hydrogens and 6 oxygens. Hopefully now it's easier to see what you have to change. We need to reduce the amount of oxygens on the product side. So instead of having 2 O2, we can have 1 O2. This means we now have 4 oxygens on the product side. So now this equation is balanced. If needed, simplify to the smallest whole number coefficient. In strategy number 2, instead of doubling everything, like strategy number 1, we'll be finding the common multiple. Let's look at the same example as before. To deal with the prime numbers, we'll be finding the common multiple between 2 and 3. To find the multiple, multiply the two numbers together. So the common multiple between 2 and 3 is 6. To make it easier, you can switch the numbers from the table onto the equation. Now we have 6 BRs on both sides of the equation, because 6 is the common multiple between 2 and 3. Keep in mind, you are not done yet. Instead of 1 copper on the product side, we now have 2 copper. So we need to put a 2 as a coefficient on the copper on the reactant side. This chemical equation is now balanced, simplified to the smallest whole number coefficient if needed. Just a note, usually you can only use this method if the element is found on one substance, not multiple on one side. For example, if Br was found on every single substance on each side, then you cannot use strategy number 2. The third strategy is the fraction method. The method is used to deal with prime numbers. If we fill in this table, we have 1 copper on both sides, and 2 bromines on the reactant side, and 3 bromines on the product side. Notice on our table, these are all prime numbers. So it's not very easy to balance this if you're not good with ratios or math. The strategy is to use a fraction as a coefficient to initially balance the chemical equation, then get rid of the fraction. The first step is to make the number of bromine on the reactant side equal to the number of bromine on the product side, which is 3. So what number times 2 will give you 3? So 2 times this number gives us 3, so this number must be 3 over 2. So 2 times 3 over 2 will give us 3. So this is the fraction that we're going to use for the coefficient of Br2. Now the equation is balanced based off this table, but we cannot have a fraction as a coefficient. So the next step is to get rid of the fraction. To do that, we multiply everything by the denominator to get rid of the fraction. So the denominator for 3 over 2 is 2. So we multiply every coefficient in the chemical equation by 2. So now we distribute the 2. 2 times 1 is 2. So now we have 2 copper on the reactant side. 2 times 3 over 2 is 3. 3 times 2 is 6. So we have 6 Br on the reactant side. 2 times 1 is 2. So we now have 2 coppers and 6 Brs on the product side. So now our equation is balanced based off this table. The last step is to either erase the parentheses or rewrite the chemical equation as your final answer. Same as strategy number 2, usually you can only use this method if the element is found in one substance on one side. For example 2, I want you to use the fraction method to balance this chemical equation. Pause the video and resume once completed. The first step is to indicate the number of atoms of each element on the reactant and product side. So we don't have to use the fraction method yet because we can still balance it. You only want to use the fraction method when you're only dealing with prime numbers and you have no other way. So we can balance the carbons first. We have to multiply the number of carbons on the product side by 2. So we put a 2 in front of CO2. So now we have 2 carbons. So how many oxygens do we have? We have 2 times 2 is 4, plus 1 is 5. Next, we want to balance the hydrogens. So notice we have 6 on the reactants, but 3 on the products. So we multiply the H2O by 3. 3 times 2 is 6. So now we have 6 hydrogens, but we got to double check the oxygens because we changed that as well. So 2 times 2 is 4, plus 3 is 7. Notice that the carbon hydrogen on both sides are equal, but the oxygen is not. For the oxygen, you're dealing with prime numbers, 2 and 7. This is a perfect situation to use the fraction method. So we want to convert the 2 to a 7. So what number times 2 will give you 7? And that will be the coefficient of this O2. So 2 times what number gives us 7? 2 times 7 over 2 will give us 7. So that will be the coefficient of O2. Now we have 7 oxygen on the reactant side. So according to this table, the chemical equation is balanced now. So the next step is to get rid of this fraction because we cannot have a fraction as a coefficient. Since the denominator is 2, we multiply every coefficient in this chemical equation by 2. So let's distribute the 2. So 2 times 1 is 2. So now we have 2 times 2, we have 4 carbons, and we have 12 hydrogens. We distribute the 2 again, so 2 times 7 over 2 is 7. 7 times 2 is 14. So now we have 14 oxygen atoms on the reactant side. We distribute the 2 again. 2 times 2 is 4. So we now have 4 carbons on the product side. And we have 4 times 2 is 8 plus 3. That's 11 oxygens. So we distribute 2 one last time. 2 times 3 is 6. So now we have 4 times 2 is 8 plus 6. That is 14 oxygens. How many hydrogens? We have 6 times 2, that's 12. So based off the table, we now have completely balanced the chemical equation because everything's equal. So we can rewrite the equation as 2C2H6 plus 7O2 gives us 4CO2 plus 6H2O. So this is the balanced chemical equation. So the next strategy number 4, is the polyatomic ion method. So you can only use this method if the polyatomic ion is present on both sides. If it's not present on both sides, you cannot use this method. The purpose of this technique is to help you count the atoms of each element because the polyatomic ions have a lot of atoms for each element, so it makes it difficult when it comes to counting for the table. So this method is supposed to make your life easy when it comes to counting. So the first step is to set a variable for each polyatomic ion. So SO4 will be X, PO4 will be Y, and you're going to write that in your table as well. You then want to rewrite the equation with the variables. Keep in mind X is set to SO4 and Y is set to PO4. So notice we simplified the chemical equation so it's much easier to balance now. So now let's fill in the table. We have 2 sodiums, we have 1 X, and we have 3 calcium and 2 Y on the reactant side. We have 3 sodiums, 1 X, 1 Ca, and 1 Y on the product side. Now we can use the regular table method to solve this chemical equation. So by looking at the table, we need 3 calciums on both sides. So we're going to put a 3 in front of the CaX so that we have 3 calciums, and we have 3X now. We next want to balance the X. So notice we have 3 on the product side, but only 1 on the reactant side. So we're going to put a 3 in front of the Na2X. So now we have 3 X's and we have 6 sodiums. Last, we want to balance the Y. So on the reactant side, we have 2, but the product side, we have 1. So we're going to put a 2 in front of Na3Y. So now we have 2 times 3, we have 6 sodiums and 2 Y. Based off the table, we finished balancing the chemical equation, so the last step is to rewrite the numbers into the original equation. Now you're done. Strategy number 5 is an extension to strategy number 4, in which the polyatomic ion, hydroxide ion, is hiding in H2O. If you see H2O on one side and hydroxide on the other side, you can use this method. This method is supposed to make it easier for you to visualize what you need to do to balance the chemical equation. So you can set H2O equal to H parentheses OH. So rewrite the equation. Now it should be easier to balance this chemical equation because now you can use strategy number 2, which is the polyatomic ion method. So we're going to set X as OH. And then rewrite the chemical equation with the variable. Now we can use the table method to balance the chemical equation. We have 1 calcium, 2 carbon, 1 hydrogen, and 1 X on the reactant side. On the product side, we have 1 calcium, 2 carbons, 2 hydrogens, and 2 X on the product side. So to balance this chemical equation, we need to double the amount of hydrogen in hydroxide. So we're going to put a 2 in front of this HX. Now we have 2 hydrogens and 2X. Based off this chemical equation, we have finished balancing the reaction. The last step is to fill in the original chemical equation. Now you're done. The last technique is the algebra method. The algebra method is a last resort technique. When everything else does not work, you'll use the algebra method. The Regents will not have any difficult ones that might require the algebra method, but in case you ever encounter a difficult balancing equation, you can use the algebra method to figure it out. It's basically treating the chemical equation as a math equation, and you'll be using some algebra to solve the math equation. The first step is to set every coefficient of every substance with a variable. So the coefficient of PCl5 will be A, the coefficient of H2O will be B, coefficient of H3PO4 will be C, coefficient of HCl will be D. Basically, you'll be using algebra to solve for the values of A, B, C, and D. The next step is to set one variable as 1. So it doesn't matter which one. I'm going to set A as 1, and we're going to solve for B, C, and D. The next step is to check the number of atoms of each element in the reactant and product side. So remember, A, B, C, and D stand for coefficients. We just don't know what they are yet. So for P, how many P's do we have on the reactant side? We have A times 1P. So we have A for the number of P's in the reactants. How about the product side? On the product side, we have C times 1P. So we have C as the amount of P on the product side. In a balanced equation, the number of phosphorus on both sides should be the same. So we're going to set A equal to C. We are going to do the same thing for chlorine. So how many chlorines do we have on the reactant side? We have A times 5, that's 5A. That's how much chlorines on the reactant side. How about the product side? We have D times 1, so that's equal to D. So we're going to set 5A's equal to D because the amount of chlorine should be the same for both sides if the equation is balanced. How about hydrogen? Hydrogen is B times 2, so that's 2B. How about the product side? We have C times 3, that's 3C, but we have a hydrogen in HCl, so D times 1 is D, so the total amount of hydrogen on the product side will be 3C plus D, and we're going to set that equal to 2B. For oxygen, we have B times 1, so that's B, that's for the reactant side. For the product side, we have C times 4, that's 4C. So we're going to set 4C equal to B. So now we're going to solve for each of the variables. So we know A is 1 because that's the variable we set as 1 in step 1. So if A is 1, then C is 1 based off this equation. Next, we can plug in A into the next equation to get D. So D will be 5 because 1 times 5 will give us 5. Since C is 1, we can plug into this equation to get B. 4 times 1 is 4, so B is 4. Now we got A, B, C, and D. We can plug into this equation to double check our answer. 2 times 4 is 8. 3 times 1 is 3, plus 5 is 8. So A is equal to 8, so it checks out. So everything is balanced now. Here are the variables for the coefficient of each substance. If you pick B or D as 1 in the beginning instead of A, you'll get a fraction. To get rid of the fraction, you have to multiply all the variables at the end by the denominator. That'll get rid of the fraction because you want a whole number for the coefficient, not a fraction. So this is the answer. You can double check your work using a table to double check whether you used the technique correct. Again, these 4 techniques are optional. Only use them if they're going to help you in a situation. They're supposed to make life easier, not harder. So try to balance these 2 chemical equations using the algebra method. Pause the video and resume once you complete it. So here are the answers. For the first one, I set A is equal to 1, and we have 3 variables, A, B, and C. Here are the two equations based off the chemical equation. Now we solve for the variables. We know A is 1, so C must be 1, and B must be 1/2 if C is equal to 1. So notice we have a fraction, so we have to multiply every variable by the denominator, which is 2. So we get A and C is equal to 2, and B is 1. So these are coefficients, and this is the answer. For the next one, we're going to use A, B, C, D as the variable, and we're going to set A as 1. So here are our equations. We have 2A is equal to C, 3A is equal to 2D, and B is equal to D. We plug in 1 and we solve for each variable. We get A is 1, C is 2, B and D are 3 over 2. So to get rid of the fraction, you multiply everything by the denominator, which is 2. So we get A is equal to 2, C is equal to 4, B and D are 3. On page 9, there's more practice that you can do that's ordered from easiest to hardest. You can check your answers using the website listed above on page 9. This concludes the video lesson. Remember to do the homework and quiz.